Yes, students, now we will see few more problems on special cases. So this is the syllabus, rotating object method, that is change of position method. It is both are one and the same. So 13th problem, draw the projections of the square pyramid of base side 60 mm and altitude. Altitude is nothing but height 100 mm when it lies on the ground on one of its triangular faces. So it is lying on ground on one of its triangular face. So triangular face is nothing but lateral face. It is slant face. So when it is lying on slant face, it means that it is a sleeping solid. Slant faces, and the solid axis is parallel to VP. So solid axis is parallel to VP. It means that the axis will be inclined to HP, right? So inclined to HP. So how will you solve this problem? Now you see this is 60 mm and 100 mm. If you do not have space in your drawing sheet, you can use the scale, reduction scale. So I am using 1:2 scale. So this is 1:2 means I am reducing by half. So it is a standard scale. So instead of 60 I can use 30, instead of 100 I can use 50, right? But I have to mention 60 and 100 only, right? So once you mention the scale, it is understood. So you are not supposed to write 30 or 50. So but you are using 30 and 50, you have to represent only 60 and 100. So that is the use of scale. So I am using scale 1:2. So it is a square pyramid. The square base side is 60 mm. So I have taken 30, but I have to mention 60 only. So 60. So this is ABCD. So it is pyramid. So you are supposed to draw thick lines to connect the apex. So this is O apex, and complete it simple front view. Now it is simple front view. So this is, I have taken 50 mm only, 1:2 scale, but still I have to show 100 mm. 100 mm. Now draw the simple front view. This is simple front view. Now you see it is resting on slant face. So this is the slant face OBC, right? OBC. So this is my slant face on which I am going to tilt this solid, right? I am making this solid in such a way that it is going to sleep on OBC slant face. So this is axis line, this is axis line. So this is axis line is inclined, but no need to draw axis line first, right? So instead you draw BCO and this angle, right? So this can be drawn with the angle, with this angle, or you can mark a point BC, right, from where you can cut arc after measuring this distance and this distance. So if you know two distances, you can cut two arcs, and the intersecting point can be your A1 dash and D1 dash. So now you complete this triangle. So anyhow, any method you can follow, so there is no restriction. Only requirement is you are supposed to reproduce this view here, right? You are supposed to reproduce this view here. So any method you can follow, no problem at all. Now draw the projectors from each and every point, from simple top view and from tilted front view, right? From tilted front view. So this is my A, sorry, this is B, right? So this is B, and this is A, right? This is A, and this is O, and this is D. It is D, right? So this is C, right? So this is how you should notate the notations here, D1. And now you draw the thick lines. All outermost lines should be thick lines. So AD is a visible edge, right? AD is a visible edge, and it should be connected with the thick line, right? So CO is CO is here, right? So this is obviously invisible edge, CO, and also BO, right? C to O should be connected with the dotted line and B to O should be connected with dotted line. So this is the simple problem where it sleep, right? Where it sleep on its triangular face on HP, right? So you have to reproduce this here, right? In sleeping problem, when it is sleeping on one of its triangular face, it means that you have to take edge on right side, right? So in this case also you have to take edge on right side. So next problem, a pentagonal pyramid of base side 30 mm and axis length, it is pentagonal pyramid 55 mm, rests on the ground on one of its lateral faces, right? Lateral surface, it is nothing but again a slant face with its solid axis parallel to VP. Draw its projections. Draw XY reference line and now draw the pentagon and complete the pentagon's simple front view on top view. Simple front view on top view. So now you have to reproduce. You have to reproduce this view here, right? You have to reproduce this view here. So similarly, anyway you can do it. So from this point you can measure this distance, right? And you can measure this distance and you can cut an arc here, and you can measure this distance from here, you can cut an arc. The intersecting point can be connected as A1 dash, and you can see, you can reproduce this view here, right? So I am reproducing the view here, and the usual practice. So draw projectors from each and every point from simple front view and tilted simple top view and tilted front view, right? So mark the points. So this is my D1 and this is A1, C1, this is C1, right? C1, and here this is you have B1 and this is A1, right? And this is E1. So E1, this is O1. Now connect all the outermost points with thick lines, right? And now you have to decide A is a visible or invisible point. A is a visible point. So A is connected to B and A is connected to E and A is connected to O also, right? Now C, D are lying at the bottom, so they are invisible edges. So DO as well as CO are invisible edges, right, in top view. So DO should be connected with the dotted line and CO should be connected with the dotted line. So this is the simple so that is the projection of this solid. Now you see it is resting on ODC, right? So this is the slant face on which it is resting, right? So these are invisible edges. These are invisible edges. So here this is the 14th problem, and 15th. A hexagonal pyramid of base side 30 mm and axis length 60 mm rests on the HP on one of its triangular faces. It is also triangular face. It is hexagonal pyramid, same as earlier problem, right? And now this is the hexagonal pyramid, and I'm just rushing through since steps are same. A1, F1, you mark these points. So from here draw the axis line, and from here to here you connect. So height is given, that is 60 mm, and you connect it. Now this is the simple front view and simple top view. Now it is resting on ODC, right? So on this slant face it is supposed to rest now, right? So now you reproduce this in such a way that it is lying on OCD. So this line should be on XY reference line, right? So now reproduce that, and corresponding top view can be projected from simple top view and tilted front view, right? So this is C1 and B1, A1, F1, right? E1 and D1. So this is O1. Now connect all the outermost points with thick lines, right? Now FC, right? FA is here. So outermost points away from XY reference line, so they are visible edges. So A1 to F1 to O, it should be thick line, and E to F should be thick line, F to A should be thick line, A to B should be thick line, F to O should be thick line, A to O should be thick line. So these are all thick lines. Now CD is away from nearer to XY reference line, right? So it is obviously lying on XY reference line. So D1 O1 can be a dotted line, C1 O1 can be a dotted line, right? So this is the final top view. So it is a final top view. It is the final top view. So now the next is similar problem. Draw the projections of pentagonal prism, right? It is a pentagonal prism of 25 mm side, axis length 50 mm, resting on HP on one of its corner, right? It is on HP, it is resting on corner. So far we have seen our edges, they are resting on edges in such a way that the two base edges passing through it makes equal inclinations with the HP. It means that it is resting on corner, right? So that corner is contained, right, by two edges. Those two edges are making equal inclination. So there it is very simple. On right hand side you mark the corner and two edges, right? It is a pentagonal prism, so two edges can be drawn here. So you just concentrate on corner, and from where you draw the two edges and then complete the pentagon. So that way you can orient this. Two base edges passing through it makes equal inclination with HP. Draw its projections when the solid axis is inclined at 30 degrees to ground and parallel to VP. So in earlier cases we have seen it is resting on edge, whereas here it is resting on corner. That is only a difference, right? Otherwise the procedure is same. Now you can see here, this is the corner on which it is going to rest now, right? These two edges are now equally inclined to VP if I tilt it, right? So that is the way we need to project this. So this is AP and give notations as usual, and draw simple front view. It is prism, right? And you should be very careful while drawing the prism. And you have invisible edge, a dotted line here, but that is overlapped by this thick line. So you can ignore dotted line. That's why you are keeping E and T within brackets, right? So this is D dash and S dash. Now the axis is 30 degrees to HP. The solid axis is inclined at 30 degrees to ground, so that is nothing but HP only, and parallel to VP. So draw 30 degree line, axis line, and the same trigonometry rule, that is trigonometry concept, you can apply and you can draw. So whatever way you do, no problem, but the only constraint is this should be reproduced here. So this is S1 dash, and this is Q1 P1 dash, and this is B1 A1 dash, C1 E1 dash, and D1, right? D1 dash. So this is the simple front view. Now you see here, this is the corner S, right? This is the S corner, and you have two edges, right? One is SR and ST, right? Those two are now equally inclined, right? So you can observe that here it is both are equally inclined to HP. So those two edges are equally inclined to HP. When it is resting on corner, so it will automatically become equally inclined. So there is no need to think much, right? So if you keep thinking, definitely you may commit in some mistake, so that can be avoided, right? So don't think much, and it will come automatically, right? So this is the projectors from simple top view and simple front view. This you can project here. Tilted front view, this is tilted front view, you can project and get the points here. So this is Q1, this is R1, right? S1, and this is T1, and this is P1, and these are the points, right? So similarly here you will get the points B1, C1, D1, E1, and A1, right? So now all outermost points you connect with thick lines, right, without any hesitation. And now this S is invisible, S is connected to T, S is connected to R also, right? They are equally inclined now, right? So S is connected to T, and here this B, right? So E to A1, E to A1 is a thick line, right? E to A1, and this is C to B, right? C to B also thick line, A to B also thick line. So these are thick lines, and A to P, right? A to P is also a thick line, and B to Q is also a thick line. Now S1 is the invisible point. The edges connecting to S1 all are invisible. So here S is connected to T, and S is connected to R, S is connected to D, right? All are dotted lines. Now you can see this is equally inclined. So S, it is resting on S, right? And ST and SR are equally inclined to HP, right? Equally inclined to HP. So that is the constraint given, and this is the final projection, and now all constraints are satisfied. So next problem, draw the projections of a cube of side 40 mm when it rests on the ground on one of its corners with the solid diagonal, with the solid diagonal vertical. So solid diagonal from it connects two opposite corners, so that line is vertical. So that way you have to draw, right? When the solid angle is diagonal, the cube should be drawn, right, in such a way that on right hand side you have a corner, right? You have a corner, so a diamond shape you can draw here like this, right? So it is it can be oriented like this. So on right hand side you get this corner, right? So this is a square. Now that diagonal can be seen in front view, right? In front view you can connect it. So now diagonal you can take either from right to left or left to right, any way you can take it. Draw it. This is the simple front view, right? This is the corners. These are the two corners. Now R to A, right? So R to A are two opposite corners. I am going to draw a diagonal, right? R to A is the diagonal. R to A is the diagonal here, or you can take P to C also. It is also correct, right? Anyway you can take, but always we are tilting from this corner, so it will be convenient and easy, and there will not be any confusion if you take R as your corner on which it is resting, and the opposite corner A dash will be on the top, right? So now it is very simple. You have to reproduce this view here, right? So first draw, measure R to R dash to A dash, that distance, and draw a vertical line. So draw a vertical line. So this is R dash, and that is 90 degrees, right? So no need to draw the axis line right away. You can complete the view. So from R to C dash you measure and cut an arc, right, on right hand side, and A to C you measure this distance and you cut an arc, right? So both arcs you can cut and you can get the point C, right? Point C. Similarly, anyhow you have drafter, so to this line you can draw a parallel line, and to this line you can draw a parallel line. You will get the P corner as well, right? P corner will be obtained. So P corner. Now you draw the remaining lines, and axis line can be drawn now, right? It will be convenient to draw the axis line now. Now you have reproduced this view here, and you have to draw the projectors from simple top view and tilted front view, right? So mark the points. All outermost points should be connected with the thick lines. Now you see this is the R, AR is the diagonal. Now both are lying at the same point, right? So now you have to decide what are all the lines should be drawn with thick lines. Now A is connected to D and A is connected to B. So A is connected to D, A is connected to B. So these lines should be thick lines, right? And now P is connected to, this R, right? This R is connected to S and R is connected to Q. So these two are invisible. Those two should be dotted lines. So R should be connected to S and R should be connected to Q, should be dotted line, right? Dotted line. Now you have A is connected with D, A is connected with D with thick line, and A is connected to D, B is also thick line. So this is, and now it is P to A, right? P to A is connected and that should be thick line, right? And here R is connected to C, right? R is connected to C, so that should be dotted line. So this is invisible edge and that should be dotted line. So this is the complete view, right? Now it is resting on AR. AR is a straight line when you see from top, right? It is a point. So both are now both are on this diagonal. So now this diagonal is perfectly vertical as per the problem statement. And this is how you should solve this problem, students. And next problem, 18th. Draw the projections of a hexagonal prism of side 25 mm and axis length, that is the height of 50 mm, resting on the HP on one of its corner in such a way that the two base edges passing through it makes equal inclination with HP. It is the same as the 16th problem. Draw its projections when the solid axis is inclined at 30 degrees to the ground and parallel to VP. So it is resting on corner, right? So these problems are corner resting problems. So here you can draw the simple top view. Now this is the corner on which it is resting. So both will be inclined if you make it to rest on HP, right? So now this is the 25 mm A1, give the notations as usual. So this is a prism. You are not supposed to draw any thick lines here, and draw the axis line, and 50 mm is the height, and draw the simple front view, right? This is the simple front view. And now draw the axis line and reproduce this view here, right? Now you know how to reproduce this view, and reproduce the view, and all the points you have to mark in the tilted front view. Now this is the tilted front view from each and every point, right? Each and every point from simple top view, and from tilted front view you have to draw the projectors. Now mark all the points, right? Mark all the points, connect all the outermost points with thick lines. Now A is connected to B, A is connected to F. They are visible edges. So F is connected with A and A is connected to B, thick line, and A is connected to 1 also, that is also thick line. So this is the top surface is completed. Now you have bottom, right? You have 4 is connected to D, so that is a invisible edge. 4 is connected to 3, that is also an invisible edge, and 4 is connected to 5, that is also will be invisible edge. 4 is connected to 5, invisible edge. 4 is connected to 3, invisible edge. Now 4 is connected to D, that will be invisible edge. So from here to here it is overlapped by thick line, but you have to show the remaining dotted line. So that is very important. Don't miss this line. If you miss any one dotted line, you may lose at least 1 mark, right? So please careful and draw the lines and decide what are all the lines, thick lines, thin lines. Those should not be missed. And 19th one. A hexagonal prism of base side 25 mm and axis length 55 mm rests on HP on one of its base corners. It is also corner resting problem. It is also prism, right? The diagonal passing through the corner is perpendicular to HP. Like we did in cube problem, the diagonal is perpendicular to HP. So this is diagonal. When you get the diagonal, it means that you have to take the corner on right hand side. So that is the logic you should understand. And now this is the simple front view. Now solid diagonal is this is the diagonal, right? So always we take diagonal from 4 to A dash to 4 dash is the diagonal. Draw the diagonal. Now that diagonal is perpendicular to HP. Now 4 dash A dash, you draw a diagonal here. Now reproduce this view, right? Now 4 to D dash you can measure, and A dash to D dash you can measure. You can cut 2 arcs on right hand side, and you can complete the tilted view, right? Tilted view, and same, right? You measure these distances and mark the corresponding points and mark the edges. And this is the tilted view, right? Now this is the tilted view. It is A and 4 is lying on the same point, right? Now project the lines from each and every point from the simple top view, and from tilted front view you draw the projectors. Now mark the points. So this is 1, right? 1 2 3 4 5 6. Similarly here we get A1, B1, C1, D1 and E1, F1, right? So these points now you mark. It is very similar, right? Same as Q problem. Now connect all the edges. All the outermost points should be connected with thick lines. Without any hesitation you do this. And A is connected to F and A is connected to B, right? A is connected to F with thick line, A is connected to B thick line, A is connected to 1 thick line, right? Now 4 is connected to 5, that is invisible edge, and 4 is connected to 3, that is invisible edge. 4 is connected to D, that is also invisible edge, right? Connect them with the dotted lines. Now this is the hexagon. Now it is standing on its diagonal vertical, right? So this is the 19th problem. Next is 20th problem. A cylinder of base diameter 50 mm and axis length 60 mm is resting on HP on a base circumferential point. So there are no corners for a cylinder, but it is resting on circumferential point, so that its axis is inclined at 45 degrees to HP. So axis is inclined to 45 degrees to HP and parallel to VP. So here the top view you can see the true shape, right? Simple top view you have to draw, and then simple front view. Simple front view is a rectangle here in case of cylinder. Now divide this into 12 equal parts, right? So divide this cylinder into 12 equal parts, and these are imaginary lines only, right? Imaginary lines, those should be drawn with a very thin line. So this is A1, B1. I am using the top points with alphabets, and bottom points I am notating with numerals. So from here to here thin line, and then draw the axis line, and this is the height 60 mm given. And now this A1, this is the edge, right? This is the generator, extreme generator, and these are all generators only, just imaginary lines. And give all the notations, right? So I am notating few here to avoid the confusion. And you have to reproduce this view here, right? You have to reproduce in such a way that the axis is making 45 degrees to HP, right? And now reproduce this, and you complete the simple front view. So this is the tilted front view. It is tilted front view. Now mark all the points, right? Mark all the points. Now as usual draw the projectors from simple top view and tilted front view. Now mark all the points. So if you have more number of points, you will get the curve, very fine curve. So that is why always I am dividing into 12 equal parts. So this is A1, B1. So all the points I am getting here. So now you have to draw the arc from C10 to 4, and then 4 to D1. It is a straight line. So D1 to J1, it should be arc. From J1 to 10 it should be thick line, right? So this is the outermost lines. Now you see 7 is here and 4 is here. So 7 to 10 and 7 to 4 are dotted lines. So you have to draw a fine dotted curve, right? A fine dotted curve. And A is here, D is here, J is here. This is visible, right? So A is connected to J, A is connected to D. This should be thick arc, and this side this should be connected with thick dotted arc, right? So this is these generators can be connected, right? These generators can be connected. No need to draw thick lines. Thin lines will do, because they are just imaginary generators. No need to draw thick lines, right? Even if you don't draw the generators, if you don't connect the generators, nothing wrong. You can leave without connecting generators also, right? So this is the problem number 20. That is the cylinder problem, right? So 21 is also a cylinder. Here solid diagonal is vertical. That is only difference between earlier problem and this problem. And solid diagonal you can draw in a simple front view, and that can be made into vertical, right? That can be made into vertical. Now solid diagonal is connecting this corner 7 to A. This is the solid diagonal. Now draw the diagonal vertical here and reproduce this view with respect to the diagonal here. So that will be your tilted front view. So this is your tilted front view now. And from tilted front view and simple top view, you projectors, draw the projectors and get the points here, right? Get the points here, and A and 7 will be lying at the same point. So that is only the difference between earlier problem and this problem. And these are the points. Again I am dividing into 12 parts to get a smooth curve. Connect it and get the outermost points. So now 10 to 7 it should be dotted line, and J to A it should be thick line, A to D, right, it should be thick line, it should be thick line, right? So connect it, and you can draw the, you can connect the generators also, right? So you can show this, and this is the cylinder when the diagonal is vertical, right? When the diagonal is 90 degrees to HP. So this is the kind of problem, and important problems. These are all university problems you can solve, right? And you can practice, and we stop here, and we will see few more problems in the next session.